chunks of code and automate their execution and execute them multiple times in a row, even billions of times in a row if you want to. So that type of control flow, they're called, these constructs are called loops. They're called loops because they, in a sense, loop over code. They take a block, just like an if statement, start at the top, execute them top down, and then start all over again back at the top, over and over and over again, in a metaphorical circle. Therefore, the name loop. It's how programmers, it's how the engineers back in the 60s started to think about it. There are two kinds of loops we're going to go over. While loops and for loops, strangely named for loops. And they all the while loops and for loops both leverage the same types, or the same constructs that we've been using before. These conditional statements, like if x is less than 10. Instead of just saying if x is less than 10, do this thing, we can say while x is less than 10, do this thing. And as x changes, that statement will be executed over and over and over again. Does that make sense? So I'm going to make a variable called x, and I'm going to write that exactly like I would an if statement. So while x is less than 10. Oh, this is going to cause problems. Notice how it looks exactly like an if statement, but it uses while instead of if. Right at this moment, the playground is executing line 84 over and over and over again as fast as it possibly can. See? Spinning away. I've given it no reason ever for x less than 10 to ever be what value? Sean, what is x less than 10 in this case? You only have two choices.
What was your question?
What is x less than 10 equal when it's evaluated in this particular statement?
It's an integer?
It is an integer. That is its type. However, if I say x less than 10, that as an expression will evaluate to what?
0?
Nope. Sorry. True. That's right. Why did he say true, Sean? Why did he say true?
Because x is currently less than 10.
That's correct.
Which is true.
That's right. So and the way the while loops work is as long as this condition is true, it keeps executing all the lines in between the braces over and over and over again, like this. Okay. So in order to expose this to you in a way that doesn't crash my computer, I'm going to put a statement. Can you hear it?
Yeah, you might want to do something quick.
This is known as an infinite loop. They're sometimes useful, most of the time they're not. But what I need to do is ensure that x starts to change in order for that condition x less than 10 to change eventually. What I'm going to do is put this simple statement down below x plus plus. Remember our incrementers? So there are different ways that I can tell x to increase its value by 1. There, x equals x plus 1, x plus equals 1, and x plus plus, and plus plus x. So in this case, what happened was this condition at the very start was true, because 0 less than 10 evaluates to true. It went through all of these empty lines and got here. And it said, okay, since I got there, the value of x I'm going to increase by 1. And therefore, x equals 1 now. 1 is less than 10. Therefore, the condition is true. And I work my way down. Then I add 1 to x. Now it's equal to 2. On and on and on again until I get to 10. 10 less than 10 is false. That's right. Because it's not or equals to 10 less than 10 equals false. So when it equals false, it's just aborts and goes directly to line 90 in this case. This is what the new playground does. Yeah, Angel's about to fall over. This is a little line chart that shows all the values that x takes from beginning to end. That's the final value that was successful for x at that moment. And these are all the values that x took during the looping process.
This is cool.
Yeah, it's pretty awesome. So if you want to upgrade to the latest version of Xcode
This is recent.
6.3.1,
7 and 8.
yeah,
This,
that's right, 6.3.1, please do so.
So that middle one, it's on 9 because that's just the last value of the.
That's the last value that was successful for this expression, x plus plus. If I put plus plus x, how would it look? I have a hunch that that's actually going to say 10.
I tried to do this and I have an error running. What do I do to get out of that?
Angel will save
Oh,
you.
okay. I deleted it because I was like, I don't want anything else to happen.
In order to demonstrate this a little bit more palpably, I'm going to create a variable that enables me to sum the numbers from 0 to 9. I'm going to show you what that looks like. Sum. Yeah.
Before it was trying to
Can we put x plus?
No. Just 2 pluses. Just 2.
What does that mean?
It means take whatever the value of x is at that moment and add 1 to it for the next line. Yeah. So if it equals 1, after x plus plus is executed, it'll equal 2. Does that make sense? That's all it does. Add 1 to x. Super simple. If you're following along, you can comment your code like this to remind yourself what's going on. You can see here this variable s, which I initialized to 0. Every iteration of the loop, I'm going to add 1. Or sorry, I'm going to add x to the value of s. Or the increment s by the value of x. So the first time is 0, so s is 0. The second time it's 1, so s is 1. The second time x is 2, so s is 3. Second, and so on and so on. I can't do that much addition by myself. Okay. Does that make sense? How this while loop works? Any questions?
Yes.
Yeah.
So you can add nodes inside of that line?
Oh yeah. Comments are
So
comments
whatever is after that, you will not consider
Yeah.
into that line.
all of the stuff. Of this stuff is ignored by Swift. So I encourage you to do this, especially when we're doing exercises in class, to remind yourself what some of these things do. We're going to endeavor as much as possible to use variable names that are long and descriptive, so that the code tends to read like English if you were to read it out loud. Such as this, if current temperature greater than 80, current temp greater than 80, stuff like that. Sometimes we need to demonstrate stuff in a more mathematical way, so we'll use single letters just to make it easier to type. But in general, I discourage you from using single letter variables, especially if they have meaning.
showing up, yeah. It would like.
So for example, this would have been better practice.
So you just want to make a block.
I just want to make it.
Okay.
It's half a
Just
point.
straight.
Just remember.
Make a point.
Okay. Thank you.
Okay. The next bit I'm going to show you has to do with is a for loop. So for loops are very similar to while loops. In fact, there are 2 types of for loops. One for loop is very similar to the construct that I just put up here.
How did you get
45. So every time the loop goes around, it executes both of these lines of code. The variable sum lives outside of here, outside of the loop, and it's initialized to 0. Every time the loop is executed, it's going to add the value of x to sum. In this line right here. Does that make sense? So the first time around, x is 0, because I say it's 0 here. And so sum equals 0. The next time around, x is going to equal 1. So this expression on the right is going to be 0 plus 1. Therefore, sum is going to equal 1. And the next time around, x will equal 2. And so this expression will be 1 plus 2. And therefore, sum will be 3. And then the next time, sum will be 3, and x will be 3. We're up to 3. So it'll be 3 plus 3, and then sum will equal 6. And slowly, one piece at a time, it'll take that value and add 1, 2, 3, 4, 5, 6, all the way up to 9 to get 45. Actually, to be complete, it looks like this. So these do the same exact thing. Does that make sense?
Yeah.
I just wrote it in an automated way. I wrote it in such a way that enables me to write, it's probably not less code, but if it were a billion, then it would be much less typing. Right? Okay. Let's say I wanted to sum all of the even numbers from 0 to 20. What are the things that I would have to change in this loop? Constantine. I mean, one thing I'd have to change in this loop. My goal is to sum all the even numbers from 0 to 20.
First you have to divide the number by 2 and you see if it's true or false. Based on that, you choose the numbers.
I divide by 2. It's not what I expected someone to say.
Is 0?
I'm sorry?
0 divided by 2 is 0.
It's 0. But then 1 divided by 2 is what?
It's 0.5. So
Is it really
has-
Is it really 0.5? What am I dealing with? What type am I dealing with here?
It's not an integer. And it has a, I don't know, hold on. It has something after the dot.
After the top.
Yeah.
Right.
But I don't
does.
know.
But here it doesn't. I'm dealing with integers here. 1 divided by 2
Is
is
it truncated?
it's truncated. That's right. So it ends up being 0. So does that get me any closer to my goal? Summing all the even numbers from 0
There
to
should
20.
be no remainders, right?
I'm sorry?
No remainders.
Yeah, I would hope not. Yeah, there's no. That's right. Okay. So let me walk through the logic that bouncing around in my head and see if it makes sense. I want to sum the even numbers from 0 to 20. So the first thing I'm going to do is just write the number 20 somewhere to make sure that I'm producing a range that's appropriate. So I'm going to change this to 20. If I want to sum the even numbers from 0 to 20, what's wrong with the conditional statement, with the condition that I've written on line 84?
It's not going to hit 20.
It's not going to hit 20. Why is it not going to hit 20, Megan?
Because the x is 0? Or do you have to change?
Nope.
Equal.
Look at it again. Why would I not hit the number 20?
Because it's less than 20?
That's right. What should it be?
Greater than?
Equal.
Or equal?
Say it out. Say it entirely. So I know that you know what it is.
While x is greater than or equal to 20?
That's
Oh, greater than or equal to 20. Let's see what happens. Oh, I get 0.
Equal to 20?
Nope. Still equals 0. You're getting close. Process of elimination. Hold on just a second. I want to see what she gets.
I'm so stressed out.
Oh, I'm sorry. There's only one. We're all friends here. There's only one left. I want this thing to be true for the value 0, 2, 4, 6, all the way to 20. So what operator do I need there to make it true for all those cases? No? Okay. It's fair. Eric, what is it?
Less than.
Less than. Okay. Does that make sense to everyone? Let me write it out. 0 less than or equal to 20 is true. 2 less than or equal to 20 is true. What I mean, less than or equal to 20. I'm sorry.
We haven't done the even magnification yet.
We have not.
Okay.
18 less than or equal to 20 is true. 20 less than or equal to 20 is true. 22 less than or equal to 20 is false. So this is the condition, this is the first condition, assuming we're counting by even numbers, this is the condition that will stop the loop. Loops keep going as long as that condition is true. And then when it reaches that condition, when that condition evaluates to false, it stops. Does that make sense? Okay. So how do I make this count by twos? Any ideas? Sorry? Plus 2. Okay, what should that line actually be? The whole line.
The line around x plus
X.
oh,
Oh no!
okay.
See what's happening? It's going out of control. Okay. Someone tell me soon before my computer explodes. Sorry? Plus equals. That's definitely one way to do it. So we're told it evaluates 11 times. If I look here, here are all the values of x for that statement.
We had as
I'm sorry?
so what I didn't change the plus equal thing.
Yeah, so the plus equals operator says take the value of x and add 2 to it.
If you don't have the equal, then
It's a different operator, so it does a different thing.
what are they both called?
I'm sorry?
Are they both called something? Or
Plus and plus equals. And in general, they're called operators. That's it. The plus operator becomes addition when we have two numerics side by side. We have an integer and an integer, or a double and a double. Then it's addition. Otherwise, it's something else. But in this case, to make it explicit, I could write x equals x plus 2, which is equivalent. Sometimes I like this because it's just much clearer what's going on. Okay, so my sum ends up being 110, and then the result is really the result of this. All right. So the loop I just did does this. It's the same thing. Go ahead.
One thing that I want to point out is if you go back to the graph, you'll notice that it looped 11 times and that the last value was actually 22. Is that what you see there?
Yeah.
Right, because when x is 20, it will do the addition and it will evaluate that while loop, that the statement in the while, and it will be false. But at that point, x is already 22.
That's right. In fact, if I were to write x here, it's 22. So 22, so this condition is actually evaluated. It actually has to check whether 22 is less than or equal to 20, which is not true.
That's something that drove me crazy in my code.
Oh, really? Yeah.
Yeah,
you can't.
There was a bug that I just didn't see that it will increment, it just won't go to that last while.
Yeah.
X is 22, not 20.
That's right. My policy, never use that variable again after it's done. So oftentimes in loops, you will have a variable that just keeps track of, it's essentially a counter that counts from one number to another. And I would recommend that you only use that counting variable within the loop. However, loops do not have to be about counting. They can be about other conditions, like continue looping until the user hits return or something like that, which I would recommend in a different way. But it's certainly something that you could do. Okay, so this in. What I want to do is show you what a for loop looks like. Okay. So the three things that went into a while loop are the fact that I declare this variable x, this condition that determines how, that answers the question, should I execute this block of code again? And then this piece that changes the value of x, changes something about the condition that ensures at some point this loop will stop. Okay, those are the three things that I need for this particular example. A for loop takes all of those and formalizes them into one syntax. So, for example, I could say for var temp equals 0, temp less than 100, temp plus equals 10. Okay. Oh, that's a bug. Look at that. Alright. So those three things. I declare a variable. With a for loop, it looks like this. The keyword for, and then this parenthetical clause here, and then another block separated by braces. So, within those parentheses exist three expressions separated by two semicolons. The first one enables me to set an initial condition. Like what happens when the loop first starts. And in this case, I'm declaring a variable called temp, and I'm initializing it to 0. The next one indicates a condition. These are the conditions under which the loop continues. This is exactly like what happens after the while keyword. And then the third one is an expression that's executed with every loop, typically used to change the initial variable that I've set, temp. So in this case, I'm going to be counting by tens. Temp will equal 0, and then it'll count by tens, on and on.
Also moves it forward. Another way to think about it, that's what moves the loop.
That is what moves the loop forward.
Right.
It gets really complicated when you start not using standard statements. And you can actually put whatever you want in each of those three places, believe it or not. So, but I wouldn't do that. No. So my favorite infinite loop is 4 semicolon, semicolon. It's awesome. Little programmer joke there, excuse me. I'll explain later. Okay, so what I want to do now is, what I'm going to do is take this that I wrote before and paste it into this clause to show you that you can actually put really complex things in. And these are all the values that come out. Oh, it all squares. Oh, it's right. Okay, I did something very wrong. You should all say 10 for one thing. There we go. Let me count by 5s to show you what might happen. Cool. Okay. So what's happening here is this temperature variable, temp, is going to start at 0. And I'm going to count by 5s. So throughout the life of the loop, it's going to equal 5, 10, 15, 20, 25, 30, and so on and so on. And the loop will stop when this condition equals false. When does that condition happen? Ned, when does that condition happen? What value of temp do I actually encounter that causes temp less than 100 to equal false? Any idea? Sorry. Say it again.
There's an obvious answer.
There's an obvious answer. Say the obvious answer.
Anything less than that.
I'm sorry. No, to equal false. Like, if you're counting by 5s, what number will cause temp less than 100 to equal false? 105 is indeed make it equal false. Is that the first one that I encountered? It's 100. Yes, indeed. So 100 less than 100 is false. So what's happening is I'm evaluating each one of these in the clauses that I've set up before. And so I get nothing 3 times. I get shorts twice. I get light jacket twice. I get sweater twice. Coat. And then parka 9 times.
If you change around the, never mind, I can just try it.
Okay, does it make sense? Do all of you attempt to write it, so attempt to write this for loop and then paste in one of the if-else clauses that you have, if you haven't already. Make sure you change the variables to something that makes sense, so that you're using the same variable name. Alright, do all of you have a for loop that's working? You try it. Alright, so there are a couple of tricky things to a for loop like this. Let me replace this with something more simple that you can replicate very quickly. I'd like you to follow along. I'm going to replace this with my freezing, boiling, liquid paradigm. And I should get liquid 13 times, freezing 7 times. I never get boiling. That's okay. Maybe I want boiling a couple of times, so I'll change 100 to 220. Oops. Maybe 300. Let's think about it like an oven in the wintertime. Okay, so as far as control flow goes, there are a couple of other tricks that we can use to control what happens with a loop like this. Sometimes I'll reach a condition under which I want to stop the loop immediately. Let's say boiling is a temperature that I never ever wanted to get to at all. And under some conditions I could get there. There are a number of ways I could stop this. I could take temp and I could change its value immediately to something great, to something where if I wanted to get there, I could change its value to something immediately greater than or equal to 300 and the loop would stop. But Swift and other languages enable us to use a technique called control transfer, which is a couple of statements that enable us to either prematurely stop a loop or to skip over parts of the block of code inside it. So one of those statements that you'll be using a lot is break. So if I don't have break in here, I hit boiling 17 times. If I have break in there, I only hit it once. Break is a statement that says whatever you're doing in this loop, stop it and jump out of the loop. So break will take us out of the loop entirely. It'll change the flow of the program to jump directly to line 118. Sorry.
Why is still doing the else last time?
It does it because my temperature starts at 0. So I hit freezing a bunch of times. And then when I hit the number 35, I actually hit liquid. It goes over and over and over and over. And then eventually I get to 215. Like this. And then the very next line is break, and so then I jump out. Okay? Okay. There's another one that's easier and makes more sense to demonstrate using a different example than boiling or whatever. So I'd like you to follow along with me if you can. We're going to write a for loop together that helps us check to see whether a number is a prime number or not. Remember prime numbers from days in mathematics? Right?
Can you define that for the shy ones?
For the shy ones? Right. Okay. A prime number, I don't even know if I remember. A prime number is a natural number greater than 1 that is only divisible by itself and the number 1. Right? Am I right?
Yeah.
Yes. So the number 7, for example, is only divisible by 1 and 7. It's not divisible by 2, 3, 4, 5, 6. So there's a really dumb way to start to check to see if a number is prime or not. That dumb way is I start with the number 2 and I divide it into that number that I'm trying to check. And then I take the number 3 and divide it in, and the number 4 and divide it in. And if the remainder of that division operation is 0, then I know it's divisible. And I stop and say it's composite, which means not prime. Make sense? So that's my loopish way of figuring out whether a number is prime. Okay. So I'll start us off with a number. Actually, is it prime? 289. Now I'm going to write a for loop that does all the counting that I want. What I'm going to attempt to do is start with the number 2 and count up until I get to the number 288. Because I know that 289 is divisible by 289, so I want to throw that case out. So I'll write for var I equals 2. So that's my initial statement. I'm going to declare a variable I, naming 2. By the way, I is a classic variable number to use with for loops. So you'll see for a lot of for loops using the variable I. Now I need a condition that enables me to count up to 289. Sorry. Let me space this out. The way I like to space it. Is it prime? So while while this condition I less than is it prime is true, it'll keep counting. Now I need a statement for I to count by ones. What should I put there? Sean, how do I count by ones?
X plus plus.
That's right, except I'm using which variable, Constantine?
Oh,
Oh, sorry. I interrupted you.
I wasn't on there.
It's okay. Megan has the answer.
Is it I plus plus?
That's right, I plus plus. It's funny, my company uses plus plus as a thumbs up on Slack. So you do like @William plus plus if you say something very clever. I have a negative score. It's minus all the time. Okay. And so the logic, you like that, don't you?
I like how much you like it.
I'm sorry?
I like how much you like it.
Yeah, oh, I love it. Okay, so the condition that I'm trying to check for, well, actually, let me just print line I, just so that I have some output over here on the right, so that I can be sure I'm doing what I think I'm doing. All right, so I start with 2, and I end at 288. It's essentially what I want. Oops. trying to mimic is, if is it prime? When divided by I, and the remainder is 0, it's composite, meaning it's not prime. All right, that's the logic that's going on in my head. So I'm going to write that out. If is it prime, and then I want to use the modulus operator because I'm looking for the remainder. So percent sign I. So that computes the remainder. When that remainder is 0, now I have a composite number. So the only way I'm going to know is if I just print composite. At this point, it's composite. This is actually a bad example for what I really want to do. 9, 13. Okay. What's wrong with this picture? I think you know 219 is 17 squared. So I knew it was composite to begin with. I'm counting from 0 to 288. What's wrong with that? Any ideas what might be wrong there? Counting too much. I shouldn't have, if I know it's composite, I know it's composite. So I shouldn't have to check it against all the other numbers. I get to 18. I get to 7, I get to 16. 289 is not divisible by 16. I get to 17. 289 is divisible by 17. Boom. And then I do 18, 19, 20, all the way up to 288. I don't need to know that. I know it's divisible by 17. I know it's not prime immediately. So I'm wasting cycles. I'm wasting compute time by trying to divide that number more than I need to. So all I have to do here is just break out of that. Now you see that number that was originally 289, or 287 rather, just changed to 16. The loop is much more efficient now. I reached the case that I was looking for, and I jumped out. Okay. Anybody else see some inefficiencies in this loop that I could take advantage of? So, if a number is divisible by 2, it's even. If a number is divisible by 4, it's also even. But if I'm counting 2, 3, 4, 5, 6, I've already divided by 2, and I know that it's even right off the bat. Right? So I don't really have to divide it by 4 either, do I? Which is a multiple of 2. And I don't have to multiply it by, I don't have to divide it by 6 either. Or 8, ever. So, one way I can, sorry.
Then something is divisible by 5, you don't have to divide
By 10, that's right. It can go on and on. So, the way that these algorithms are done most efficiently is I have a set of prime numbers that I know already, and I'm just dividing by all the prime numbers that I know up to the square root of the number that I'm checking. Does that make sense? I think that's generally the most efficient way of solving this problem. But the point that I'm going to make here is that there's a way to start skipping numbers that I don't want to check. And so one way to do that is let me assume for a moment that I know that it's, okay, well, no, I'll just do it this way. So aside from break, there's another statement that I can use that controls how this loop is executed. That statement is called continue, and its semantics are a little bit different. Break stops the loop and jumps out. Continue says wherever you are, start the loop over again. Like it skips everything else past the continue statement, and then it starts back up at the top of the loop again. Does that make sense? So in this case, what I want to check for is if I is a multiple of 2, which means the remainder is 0 when I divide by it, and I is greater than 2, then continue. See that 16 just changed to 9? I saved myself 7 iterations.
Do you need the print line, printing the I down the block?
This one?
Yeah.
No, you don't. I mean, I'm doing that so that a number shows up here. And also print line instead of just a naked I because I want to get us some good habits. Okay, so that's a little complicated, but let me show you again what's going on. So here, I'm going through this group 287 times. I'm checking every number from 2 to 280, 2 to 288. Very inefficient. So when I reach the number 17, I know that 289 is immediately divisible by 17. So I don't really have to run the loop anymore. Using break, oops, sorry, let me do that again. So 287, we see on line 128. If I put break in here, I get the same result, the fact that this is composite, but I've only run the loop 16 times. That's just to demonstrate that I can stop a loop early, and in this case, in the service of a more efficient prime number checker. In this case, technically a composite number checker. So this statement attempts to skip all the even numbers after 2. Because if a number is divisible by 2, I don't have to check any even numbers before. I actually don't have to check any of them. So I could just break out of it entirely. But I want to demonstrate what continue does. So what this if statement here, this if clause right here does, is it checks to see if I is an even number, which is this. The remainder when divided by 2 is 0. And it checks to see if I is greater than 2, because I actually want to check 2, because I want to grab all the even numbers and chuck out immediately if I have to. Yes?
Sorry if this is repetitive, but could you just go over what the 2 equal signs mean again?
Oh, this one?
Yeah.
This is equality. So if I have a number and it's equal to another, I can check by using 2 equal signs.
Okay.
Yes.
Thank you.
So in this case, if I have an even number greater than 2, I can continue and break out of this. Another way to write this might be this. I don't know if this will confuse you or not. This is the same kind of logic, but it starts to break everything apart and use variables to make the code more readable for you. So if you, but remember what I told you two before in the analysis. The evils of the programmer is breaking down the problem into smaller parts. So this is one of those examples. So I could actually say let is greater than 2 equal I is greater than 2. Now I actually have a human readable if statement. If is even and is greater than 2, continue. So what continue does is it says skip all of this stuff and go back to the top of the loop again, over and over. Continue stops. Break stops the loop entirely, jumps out. Continue skips everything past the continue statement and starts at the top again.
And you say keep going back.
That's right. But yeah, I can say but keep going. It means the loop doesn't stop. It just skips the rest of the block for that iteration.
Quick question.
Yes.
It's definitely repetitive. Is the I, is that divided by 2 or?
This says compute the remainder when you divide by 2.
Okay.
Yeah. So it returns so it does do division, but instead of returning the answer of the division operation, it returns the remainder. Right?
So if I is 4.
And then the remainder will be 0 here.
Okay. Oh, I see.
right? So,
Oh, the remainder. Yeah.
yeah, the remainder, the
Okay.
mathematical remainder. Playground sometimes. Does that make sense? So 4 is divisible by 1, it's divisible by 2, and it's divisible by 4, but it has a remainder of 1 when divided by 3. So this is actually what we're leveraging to figure out if a number is prime or not. We know 4 is not prime because it's divisible by 2. Okay, so these are examples I can post for you all later if you want to read through them. Actually, the slides have the prime number examples, so that's good. 846. All right. All right. So the next phase, loops are a bit complicated, and it's going to take a while to get used to them. If you haven't heard it before. Let me break this up a little bit. But the point is that I can't change this number and ascertain whether something is prime. I would love to know what it's divisible by, so I'll interpolate the value I, divisible by 3. So this number is prime because it never shows composite. It never shows this. So I reach the end and then it's known to be a prime number.
So you can put Alice.
Not in this case. It's a little complicated because knowing that something is not divisible by a single number doesn't mean that it's not divisible by the next number. So I can tell if something's composite very easily, but actually definition of prime is really not composite. So the way that I would keep track of that is by, one example would be to have another variable, which is prime, and set it to true. Just assume that it's prime to begin with, and then have this clause set it to false. Does that make sense? Break out, and now is prime. That's right. So I can do that. And I set it to, and I use var because I want it to be a variable. There, it's true. 239 is indeed prime. I hope. Okay. I'll show you a couple more things. And then I think we'll probably try to tackle the rest of the activity from last time. But I want to get you more experience coding. The last thing I want to show you, I guess I can show you a bit about functions. But the last thing from last class I want to show you is this thing called an optional. There are a lot of cases in which we'll have a variable, but we won't have a value to put into it yet. Remember, variables hold values of a particular type. But there are a lot of cases in reality when it doesn't really make sense to have a value assigned to a variable or not. Things like a web request, for example. If I'm making a web request from my phone to a server, it takes time for that request to finish, right? It can be a millisecond, but it can be 30 seconds, depending on how slow that server is. I would normally want a variable to hold the response to that request, right? Like, get someone's bio from their Facebook profile or something. But I would want to have a variable that's bio at one moment to make my code correct, but I wouldn't have a value for that yet. So